March the 6th, 2015. This is CISG114, Section 1, Web Technology and Life. Today is day number 14 in the week number 7. So let's get started. Okay, thank you very much for coming back during this lunch hour. Sometimes it's very difficult for people. Now, if you look at your assessment record, I've already done some assessment record and sent this out to you this morning. So you can see that I've already finished grading your learning contract number 1. You can see that I've given you some comments there. Now remember, each learning contract is just 10 points. It's not much. Okay, it's meant for you to learn something from it and get the feedback. One thing that I discovered over all the items is the block. I think I need to emphasize a little bit. The block is not something that you can take it lightly. The block is actually a final product, which should have an essence of what you did in the previous report, discussions, and journals. Okay, so if you look at the comments I've given you on the block, you should actually nail down the block by pinpointing on the topic you select for discussions, example you discover, and include some sources there, because it's basically a final product. If you, when I finished reading the block, I discovered that maybe you do not quite understand the meaning of the block. It's actually more important than the report. Okay, the report is what we call a formal way of reporting on a specific learning that you did with your learning partner. But when you write the block, it's basically how you extract the most important things from your report and also from your learning. Okay, so the block normally goes from 300 words to 500 words, and it contains the references. So I hope that when you do the block again in the second learning contract, you put a little bit more attention there. Okay, so this is basically the block here, and I've given you some feedback. All right, so you can go back and take a look at it. And for those of you who forgot to submit your homework in the first learning contract, please do not forget to submit your work in the second learning contract before the end of this week, because you need that experience in order to carry forward to your last learning contract, which is going to happen starting next week. Okay, and remember, I told you already that the last learning contract is meant to be a group work all together in class, and so you need to be getting ready for the 1.5 hour work, actually 1 hour and 15 minutes work in class, to see how much you can accomplish at the end of that 3 weeks period for the last learning contract. Now, it does not mean I will not give you points of interest. I will still giving you hints on topics of the 3 weeks, starting from week number 8, number 9, and number 10. But the most important thing is you must get ready for in-class teamwork. Okay, now having said that, let's get to the very interesting topic on taxonomies and tagging. Well, I feel a little bit hot, so let me just take this off. It's a little bit cold outside today, but inside it's very good. We're going to talk about taxonomy. The idea of taxonomy is very interesting. It's a combination of 2 words, folks and nomies, taxonomy. So it's the taxonomy used by common people. Okay, what is meant by taxonomy used by common people? It's a categorizations we use to divide things, to indicate the differences between things. So you can see that tag means to put a label on. And the tag is basically a label, which is a type of metadata. And if you want to study a little bit deeper, it belongs to the discipline on ontologies and how you can classify things. But in the web, because we have a lot of different things from common people, we come up with the word taxonomy for categorizations. So let's get to it.
Thanks for joining our Web 2.0 class. This is your instructor, Teresa Papa. Today I would like to talk about folk songs. Oh, excuse me. I mean folksonomies.
She's a funny teacher.
folksonomy, or folksonomies, comes from the word folk and taxonomy. It was coined by Thomas van der Waal around 2004. The definition of a folksonomy is it is the practice and method of collaboratively creating tags to annotate and categorize content. A taxonomy is a structured classification system. It is controlled by authorities and it has rules, regulations, guidelines. A folksonomy, on the other hand, consists of freely chosen keywords. There are no restrictions, and the user can generate them. They can also be collaboratively generated. So a folksonomy is used to identify content with labels that are called tags. These tags are chosen by the user. They are used to define the content, to find the content later. They are available to the public, and they can be added by others in many instances. Why do we need a folksonomy? Well, from the very beginning of the internet, we use the web for finding information. The current methods that we have been using do have limitations. And since there is such a vast amount of information out there today, and since the information is now existing in different media formats, we need better ways of finding information, or may I say additional ways of finding information. So a folksonomy provides meaning or metadata to the content. It is also used to generate communication about the content. It is used in the sharing of knowledge concerning that content. And it is also used to retrieve the information. It is used to search for it and to go back and find it again. Some sites that use folksonomy, Flickr is credited for being the first, although Delicious, which we will look at next week, I think technically was the first. YouTube uses folksonomies, Library Thing, and Amazon. Actually, as we get on in the course, you will see mostly all of the applications that we are using use folksonomies. Let's take a look at tags. A tag isn't the game you played as a child, and it isn't something you put on luggage, although that's close. A tag is a label, and it's used to associate some kind of meaning. We can use a tag on a photo, on video or audio, on a book, on a web page, or other resource. These tags are user-defined, informal, and available to the public. They can be seen by the public. Let's take an example of how we might tag this animated photo here. We could say it is a white dog. We could say it is an animated dog. We could say a bouncing ball is representative of this. A dog. Dog playing ball. And a red ball. And I'm sure you can think of many other types of phrases that would represent this picture that we see. So We use tags to associate meaning to some type of web content. So to review, the tags give meaning, associate information. They are used in searching for information, and they're easy to use and understand. A tag cloud is a visualization of the most popular or most frequently used tags. Here we see an example of a tag cloud that might be used on, say, a blog that had a lot of information about these different areas. These would all be different tags that collectively represent information, and obviously Web 2.0 would be the most popular tag, but we see that some stand out more than others. So we will take a look at Flickr next to understand how tags can be used in a realistic setting.
Okay, now we would stop here first and to make sure that you got the ideas of tagging and taxonomy. Now, the funny lady have given you a very slow but very easy to understand mini lecture on what is meant by a tag. How do you do tagging by looking at an animated picture, and the difference between the taxonomy and taxonomy. Taxonomy belongs to the very professional people's work. It must be regulated by authority. Taxonomy is any keyword freely used by you and me as a common people. So, and we use tagging a lot when we use Delicious, which is also bookmarking, when we use Amazon, so when we read the book, we tag it, when we use YouTube, okay? And then, what is meant by tagging, okay? So you do something about this. Now let's try to see another picture in green English. Just 3 minutes.
What is tagging? Tagging is simply one way of categorizing content that you want to find again in the future. A lot of people are already familiar with using folders and subfolders to organize their files. Well, tagging is just a different way of accomplishing the same sort of thing. Folders and subfolders tend to work well if you have a well-structured way of organizing your files, whereas tags tend to work well when you don't. Let's look at an example using both folders and tags. Let's say I'm shopping for a new car, and I've narrowed down my choices to 3 new cars and 3 used cars. First, let's see how I might use folders to organize my work. For each of the new cars I'm looking at, I want to see the information on the company website, I want to check out the reviews on Edmunds.com, and I want to read the online forums. And for the used cars, I want to do pretty much the same thing, but I also want to organize the listings I find for cars that are for sale online. So I first create a directory structure to store the web pages, and then I can file away each page into the appropriate place. Here's the web page for the Edmunds review of the Ford Mustang. So I'll drag the web page into the subfolder for Ford Mustang under the folder for new cars. Now, let's look at how we might organize this information using tags instead of by folders. Let's take this Edmunds page for the Ford Mustang and assign some tags to it. I'll assign the tags Ford Mustang and Edmunds by clicking on those tag names, and you can see now that those tags have been assigned to this page. This is the same thing as physically putting a set of labels or sticky notes on the Edmunds review for the Ford Mustang. One of the benefits of organizing by tags instead of by folders is that you can assign multiple tags to an object, and you don't have to think about creating an organizational structure beforehand or having to remember where you put something when you want to retrieve it. By using tags, the objects can be found by searching on any of the tags. So if I look under the tags for Ford Mustang, my Edmunds review is there. Or I can drill into the Edmunds tag under Ford Mustang. Or if I look just in the tag for Edmunds, I'll see all the admin's reviews. So here I get to see the admin's reviews for all of the cars, even though I didn't think to set it up this way. Let's say now I want to see the infinity listings. I can drill into the infinity tag, or if I want to see only the infinity listings, I'll drill into the for sale tag under infinity. But let's say I want to see all the listings for all of the cars. You guessed it. I can drill into the for sale tag and I see all of the cars. Since I didn't organize my folder structure that way, I can't easily do that with my folders. So sometimes folders provide a better approach to organizing than tags, and sometimes tags work better. If you have a rigid organizational structure, you might want to use folders. If you're saving and organizing things in sort of an ad hoc manner, then tags might work best. And sometimes you might want to organize your files using both tags and folders. Some systems now support both methods of organizing your data. So thank you very much for watching our video on tagging. We hope it was helpful.
Well, I hope it's going to be helpful to you too. Do you have a slight little picture of what is meant by tagging now? Using the very specific examples given by the gentleman here. So you use folder as a classification system to put into the suitable folder what is supposed to be there, right? Everybody know how to use it with your computer, with your computer explorer, you do something like this. But instead, they help you to understand it from a tagging point. Use the tag to do something similar. Have you ever used tag to do something like this? Say you physically create a piece of paper and you use that piece of paper to collect as many tags as possible. The tags includes information that is very much peculiar to that piece of paper. But that is very interesting. Okay? Now I have more than one video there to help you to broaden your perspective. Alright? So it's very important. But now I would like to show you a little bit differently. So let's talk about metadata. Okay? We go step by step. What's meant by metadata?
Hi, I'm Jared Hillam. Sometimes in the IT world, we have names for features and capabilities that seem to be tailored for a business user's confusion. One such word is metadata. Admittedly, when I first heard this word, I struggled to conjure up my rusty Greek prefixes. However, the concept of metadata is actually quite simple. Metadata is essentially information about data. Examples of metadata are all around us, especially in our digitally connected world. So let's give some examples of technical metadata and business metadata. Imagine our piece of data is a customer ID. Technical metadata around this customer ID might be what table does that ID reside in, or what kind of data type is it. However, the metadata businesses get excited about is business metadata. See, business metadata provides meaningful insight to the business about the data they're storing. Surprisingly, most data does not naturally present itself in ways that are meaningful to the business. This is because transaction systems use the data for their own internal workings and not to chat with the business. This is where business intelligence tools enter into the picture. The most powerful BI tools have sophisticated business metadata design utilities, which allow business definitions to be associated to the data. In turn, this empowers business people to both interact with and understand what the data is. Intricity specializes in the design of these systems, and we've enabled many organizations with greater insight into their business. I encourage you to go to Intricity's website and talk with one of our specialists so that we can help you transform your raw data into meaningful information.
Okay, now you got some ideas. Let's try to pinpoint what the idea is. If I invite you to take a look at your student ID, okay? Each one of you have a student ID. So the first interesting interpretations of the metadata is what type of data is your student ID? What type of data? Does it contain letters? Does it contain numbers? Does it contain special punctuation symbol like hyphen? So if it contains all of these, how are we going to classify the data? Is it alphanumeric? Alpha means letter, numeric means digit. So it's a kind of alphanumeric data. So first of all is the type of the data. Okay? This next question is, when you present your student ID, what do you think is being stored by the school? Is your student ID stored in one cabinet? Is your student ID stored with your data in the registry? Or is your student ID being stored with some kind of folder with respect to your faculty? Or is your student ID being stored where you reside now, that is your residential college? So basically, this is a very interesting question, okay? How is the data created, with what type of data, and where it is stored, and how it's being used, okay? So metadata. Well, the next thing we need to ask is, what's the application of student data? Well, for example, your student ID. Why do you need a student ID? At what occasion is your student ID important for you? When you do pre-enrollment of the courses, okay? When you want to obtain a special privilege, for example, a discount on the purchase of a book, you must produce a student ID. When you want to get a free access to Microsoft software for students, you must present a student ID. And sometimes more than a student ID is important as the website you link. Okay? Now, you understand something about metadata. If I would have to summarize what is meant by metadata, it's the data about data. Okay? It's the data about data. Meta. What about ontology? Okay, one level up.
An ontology can be defined as a model which represents knowledge as a set of concepts within a domain. An ontology also captures the relationships between these concepts. An ontology is a form of knowledge management. It captures the knowledge within an organization as a model. This model can then be queried by users to answer complex questions and display relationships across an enterprise. Today, people have access to more data in a single day than most people had access to in a lifetime in previous decades. The problem is the data is found in many different forms. All of this information, captured in many different formats, makes it almost impossible to understand existing relationships between different data. In this current environment, it is very difficult to determine how policies, captured in Word documents, relate to business processes, captured in models, and how those business processes relate to data, captured in the database. Data needs to be represented in a format that allows these types of relationships to be discovered. Ontologies capture data in a way that allows these relationships to become visible. The two standards which govern the construction of ontologies are the Resource Description Framework, or RDF, and the Web Ontology Language, or OWL. In accordance with RDF and OWL, ontologies are made up of two main components: classes and relationships. Classes are represented as ovals, while relationships are represented by arrows. Let's take a look at a particular example. In this example, there are two classes, person and organization, each representing a real-world concept. There is also a relationship that is, has employer. Together, these classes and relationships can be combined to assert statements about the real world. In this example, the class person is related to the class organization through the property has employer. We can use ontologies to begin describing real-life relationships. For example, Todd is an instance of the class person, and Spry Inc. is an instance of the class organization. Ontologies capture the relationships between these two instances. In this example, Todd has employer Spry Inc. The combination of classes and relationships is known as a triple. A triple consists of a subject, a predicate, and an object. Triples lay at the heart of ontologies. They can be merged together to provide a comprehensive view of the real world within an ontology. Within an ontology, concepts are only defined in terms of their relationship to other concepts. For example, say we are describing a concept called mystery person. Mystery person has many relationships to other concepts, including gender, date of birth, race, hair color, and address. We can use these relationships to define the mystery person. Can you guess who it is? Ontologies through RDF and OWL are designed and structured to capture such relationships. Ontologies are also easily extensible. Rather than rewriting lines of code, new relationships can easily be added to existing ontologies. We simply add additional relationships which link person to new concepts. This process continues and ontologies are extended without disrupting the work that is ongoing or already completed. One of the most popular aspects of ontologies, in addition to capturing relationships, is that using ontologies for knowledge management is an alternative to source code. Many approaches capture knowledge and relationships established by different working groups as lines and lines of source code. This approach, while still popular, is extremely hard to manage, can be managed only by a small group of engineers who understand the code, and cannot easily adapt to changes in the environment. Ontologies present a new method in managing knowledge and capturing relationships, one that encourages more individuals to become directly involved. Using models rather than lines of code also allows ontologies to be easily modified with the changing environments. This makes ontologies a sensible choice for any large, ever-changing organization.
Okay, now you have seen the first picture of what we call formal understanding of ontology in relations to knowledge management. Now, just going back now, we have given you a very interesting picture showing you what we call the labelment system of classifications called taxonomy, and the labelment system of doing the classifications called tagging. And then we showed you a little bit more about tag in the context of computer files management. And then we also given you plain English interpretations of tagging and the metadata and then ontologies. So guess what? We're going to give you a glimpse of what we meant by the next web open linked data. Okay, so this is presented by Tim Berners-Lee, and do you know who this person is? He's the guy who created the World Wide Web. Okay, and actually, when he created World Wide Web, he has a different picture of what it should be like. And unfortunately, this picture has not been fully realized, but it's gone into very interesting directions. And in this very simple talk, we would like to introduce to us something called the open linked data. Now, I want to challenge you to see how much you understand from Tim Berners-Lee's own interpretations of this. Okay. At the end of that, I will show you how to work with the wiki in the specific window system. Oh, maybe we can do it next week because we have meetings like a PBL. Oh no, not this way, not this one. This one. All right. We're 16 minutes time with Tim Berners-Lee. Okay. Let's see. Let me just kick it on.
Time flies. It's actually almost 20 years ago when I wanted to reframe the way we use information, the way we work together. I invented the World Wide Web. Now, 20 years on, Ted, I'm to ask your help in a new reframing. So going back to 1989, I wrote a memo suggesting a global hypertext system. Nobody really did anything with it very much. But 18 months later, this is how innovation happens. 18 months later, my boss said I could do it on the side as a sort of a play project. Kick the tires of a new computer we got. And so he gave me the time to code it up. So I basically roughed out what HTML should look like, hypertext protocol, HTTP, the idea of URLs, these names for things, which started with HTTP. I wrote the code and put it out there. Why did I do it? Well, it was basically frustration. I was frustrated. I was working as a software engineer in this huge, very exciting lab. Lots of people coming from all over the world. They brought all sorts of different computers with them. They had all sorts of different data formats, all sorts of kinds of documentation systems, so that in all that diversity, if I wanted to figure out how to build something out of a bit of this and a bit of this, everything I looked into, I had to connect to some new machine, I had to learn to run some new program, I would find the data, maybe the information I wanted in some new data format, and these were all incompatible. It was just very frustrating. The frustration was that there's all this unlocked potential. In fact, on all these disks, there were documents. So if you just imagine it all being part of some big virtual documentation system in the sky, then, say, on the internet, then life would be so much easier. Well, once you've had an idea like that, it kind of gets under your skin, and even if people don't read your memo, actually he did. It was found after he died, his copy, it was found he'd written vague but exciting in pencil on the corner. But in general, it was really difficult to explain what the web was like. It's difficult to explain to people now that it was difficult then. But then, okay, when TED started, there was no web. So things like click didn't have the same meaning. I could show somebody a piece of hypertext, a page which has got links, and we click on a link and bing, there'll be another hypertext page. Not impressive. You know, we've seen that. We've got things on hypertext on CD-ROMs. What was difficult was to get them to imagine. So imagine that that link could have gone to virtually any document you could imagine. All right, that is the leap that was very difficult for people to make. Well, some people did. So yeah, it was difficult to explain, but there was a grassroots movement. That is what made it most fun. That was being the most exciting thing, not the technology, not the things people have done with it, but actually the community, the spirit of all these people getting together, sending the emails. That's what it was like then. Do you know what? It's funny, but right now it's kind of like that again. I asked everybody, more or less, to put their documents. I said, could you put your documents on this web thing? And you did. Thanks. It's been a blast, hasn't it? I mean, it's been quite interesting because we found out that the things that happened with the web really sort of blow us away. They're much more than we'd originally imagined when we put together the little initial website that we started off with. Now, I want you to put your data on the web. Turns out that there is still huge unlocked potential. There is still a huge frustration that people have because we haven't got data on the web as data. What do you mean data? What's the difference? Documents, data? Well, documents you read, okay. More or less you can read them, you can follow links from them, and that's it. Data, you can do all kinds of stuff with the computer. Who was here, or otherwise seen Hans Rosling's talk? And Hans Rosling's with TED, yeah, one of the great, yes, a lot of people have seen it because it was one of the great TED talks. Hans put up this presentation in which he showed, for various different countries in various different colors, he showed income levels on one axis, and he showed infant mortality, and he showed this thing animated through time. So he's taken this data and made a presentation which just shattered a lot of myths that people had about the economics in the developing world. He put up a slide a little bit like this. It had underground all the data. Okay, data is brown and boxy and boring and other. That's how we think of it, isn't it, data? Because data you can't naturally use by itself. But in fact, data drives a huge amount of what happens in our lives. And it happens because somebody takes that data and does something with it. In this case, Hans had put the data together. He found it from all kinds of United Nations websites and things. He put it together, combined it into something more interesting than the original pieces. And then he put it into this software, which I think his son developed originally, and produced this wonderful presentation. And Hans made a point of saying, look, it's really important to have a lot of data. And I was happy to see that at the party last night that he was still saying very forcibly, it's really important to have a lot of data. So I want us now to think about not just 2 pieces of data being connected, or 6 like he did, but I want to think about a world where everybody has put data on the web, and so virtually everything you can imagine is on the web. And I'm calling that linked data. The technology is linked data, and it's extremely simple. If you want to put something on the web, there are 3 rules. First thing is that those HTTP names, those things that start with HTTP:, we're using them not just for documents. Now we're using them for things that the documents are about. We're using them for people. We're using them for places. We're using them for your products. We're using them for events. All kinds of conceptual things. They have names now that start with HTTP. Second rule, if I take one of these HTTP names and I look it up, I go and do the web thing with it, and I fetch the data using the HTTP protocol from the web, I will get back some data in a standard format, which is kind of useful data that somebody might like to know about that thing, about that event, who's at the event, whatever it is, about that person, where they were born, things like that. So the second rule is I get important information back. The third rule is that when I get back that information, it's not just got somebody's height and weight and when they were born, it's got relationships. Data is relationships. It's interestingly, data is relationships. It's got this person was born in Berlin. Berlin is in Germany, and when it has relationships, whenever it expresses a relationship, then the other thing that it's related to is given one of those names that starts HTTP. So I can go ahead and look that thing up. So I look up a person. I can look up then the city where they were born, then I can look up the region it's in, and the town it's in, and the population of it, and so on. So I can browse this stuff. So that's it, really. That is linked data. I wrote an article entitled Big Data a couple of years ago, and soon after that, things started to happen. The idea of linked data is that we get lots and lots and lots of these boxes that Hans had, and we get lots and lots and lots of things sprouting. It's not just a whole lot of other plants. It's not just a root supplying a plant, but for each of those plants, whatever it is, a presentation, an analysis, somebody's looking for patterns in the data, they get to look at all the data and they get to connect it together. And the really important thing about data is the more things you have to connect together, the more powerful it is. So, linked data. The meme went out there, and pretty soon Chris Bitzer at the Freie Universität in Berlin was one of the first people to put interesting things up. He noticed that Wikipedia, you know Wikipedia, the online encyclopedia with lots and lots of interesting documents in it? Well, in those documents, there are little squares, little boxes, and in those information boxes, there's data. So he wrote a program to take the data, extract it from Wikipedia, and put it into a blob of linked data on the web, which is called DBpedia. DBpedia is represented by the blue blob in the middle of this slide, and if you actually go and look up Berlin, you'll find that there are other blobs of data which also have stuff about Berlin, and they're linked together. So if you pull the data from DBpedia about Berlin, you'll end up pulling up these other things as well. And the exciting thing is it's starting to grow. This is just the grassroots stuff again, okay? Now let's think about data for a bit. Data comes, in fact, in lots and lots of different forms. Think of the diversity of the web. It's a really important thing that the web allows you to put all kinds of data up there. So it is with data. I could talk about all kinds of data. We could talk about government data. Enterprise data is really important. There's scientific data, there's personal data, there's weather data, there's data about events, there's data about talks, and there's news, and there's all kinds of stuff. I'm just going to mention a few of them so that you get the idea of the diversity of it, so that you also see how much unlocked potential. Let's start with government data. Barack Obama said in a speech that American government data would be available on the internet in accessible formats. And I hope that they will put it up as linked data. That's important. Why is it important? Not just for transparency. Yeah, transparency of government is important, but that data, this is the data from all the government departments. Think about how much of that data is about how life is lived in America. It's actually useful. It's got value. I can use it in my company. I could use it as a kid to do my homework. So we're talking about making the world run better by making this data available. In fact, if you're responsible, if you know about some data in government department, often you find that these people, they're very tempted to keep it. Hans calls it database hugging. You hug your database, you don't let it go until you've made a beautiful website for it. Well, I'd like to suggest that rather before you, yes, make a beautiful website, who might say don't make a beautiful website, make a beautiful website, but first, give us the unadulterated data. We want the data. We want unadulterated data. Okay, we have to ask for raw data now, and I'm going to ask you to practice that, okay? Can you say raw? Raw. Can you say data? Can you say now? Right. Raw data now. Raw. Practice that. It's important because you have no idea the number of excuses people come up with to hang on to their data and not give it to you, even though you've paid for it as a taxpayer. And it's not just America, it's all over the world, and it's not just governments, of course, it's enterprises as well. So I'm just going to mention a few other sorts of data. Here we are at TED, and all the time we are very conscious of the huge challenges which the human society has right now. Curing cancer, understanding the brain for Alzheimer's, understanding the economy to make it a little bit more stable, understanding how the world works. The people who are going to solve those are scientists. They have half-formed ideas in their head. They try to communicate those over the web, but a lot of the state of knowledge of the human race at the moment is on databases, often sitting in their computers, and actually currently not shared. In fact, I'll just go into one area. If you're looking at Alzheimer's, for example, drug discovery, there is a whole lot of linked data which is just coming out because scientists in that field realize this is a great way of getting out of those silos, because they had their genomics data in one database and in one building, and they had their protein data in another. Now they are sticking it onto linked data, and now they can ask a question that you probably wouldn't ask, I wouldn't ask, they would. What proteins are involved in signal transduction and also related to pyramidal neurons? Well, you take that mouthful and you put it into Google. Of course, there's no page on the web which has answered that question because nobody has asked that question before. You get 250,000 hits, no results you can use. You ask the linked data which they've now put together, 32 hits, each of which is a protein which has those properties. And you can look at the power of being able to ask those questions of a scientist. Questions which actually bridge across different disciplines. It's really a complete sea change. It's very, very important. Scientists are totally stymied at the moment. The power of the data that other scientists have collected is locked up, and we need to get it unlocked so we can tackle those huge problems. So if I go on like this, you'll think that all the data comes from huge institutions and it's nothing to do with you. But that's not true. In fact, data is about our lives. You log onto your social networking site, you pick your favorite one, you say, this is my friend, bing, relationship, data. You say, this photograph, oh, it depicts this person, bing, that's data. Data, data, data. Every time you do things in the social networking site is taking data and using it, repurposing it, and using it to make other people's lives more interesting on the site. But when you go to another linked data site, and you say, this is one about travel, and you say, I want to send this photo to all the people in that group, you can't get over the walls. The Economist wrote an article about it, and lots of people have blogged about it. Tremendous frustration, the way to break down the silos, to get interoperability between social networking sites. We need to do that with linked data. One last type of data I'll talk about, maybe it's the most exciting. Came down here, I looked up on the OpenStreetMap. OpenStreetMap's map, but it's also a wiki. Zoom in, and that square thing is the theatre which we're in right now, the Terrace Theatre. It didn't have a name on it. So I could go in edit mode, I could select the theatre, I could add on down the bottom the name, and then I could save it back, and now if you go back to the openstreetmap.org and you find this place, you will find that the Terrace Theatre's got a name. I did that! Me! I did that, it's the map! I just did that, I put that up on there. Hey, you know what? That street map is all about everybody doing their bit, and it creates an incredible resource because everybody else does theirs. And that is what linked data is all about. It's about people doing their bit to produce a little bit, and it all connecting. That's how linked data works. You do your bit, everybody else does theirs. You may not have lots of data which you have yourself to put on there, but you know to demand it. And we practice that. So linked data is huge. I've only told you a very small number of things. There are data in every aspect of our lives, every aspect of work and pleasure. Okay? And it's not just about the number of places where data comes. It's about connecting it together. And when you connect data together, you get power in a way that doesn't happen just with the web, with documents. You get this really huge power out of it. So we're at the stage now where we have to do this. The people who think it's a great idea, and all the people, and I think a lot of people at TED, who do things, because even though there's not an immediate return on investment, because it'll only really pay off when everybody else has done it, they'll do it because they're the sort of person who just does things which would be good if everybody else did them. Okay? So it's called linked data. I want you to make it. I want you to demand it. And I think it's an idea worth spreading. Thanks.
This is called a TED Talk, and there are different types of TED Talks, but this one is called TED Talks that with the ideas worth spreading. Okay, let me just stop that first. My computer does not allow me to do that. Okay. Here we go. Yes. All right. So let's go back to take a look at what we're interested in helping you to understand today. Now we go through the typical sequence of showing you what is meant by the layman's way to classify data. Now the emphasis is not on data at the very beginning, it's on classifications, and then we use the keyword tag to help you to understand the meaning of doing these classifications. Put an emphasis there, put a label there, and then we show you a little bit on the meaning of metadata, data about data. And then we give you a glimpse of the picture of ontology, which is something to do with knowledge management, and then we bring you to this Tim Berners-Lee's talk, which talks about his idea of open linked data. Now the talk is very short, 16 minutes, but it has a lot of very important messages. And one of these messages is each one of us, when we set up our own website, it is not just the website itself that is important, it's what kind of data we can put there to serve the world. If it is not for the fact that someone put the data there, we cannot discover what we discover today when we go to Google. Okay? So each one of us, if we could do a little bit of this, we can contribute to the knowledge of the world that it's accessible to all the people. But the point here is raw data, not the process data. What is meant by raw data? Raw data represent the data which cannot be interpreted directly as it is, but collectively speaking, you can see a pattern of this. Okay? For example, if you're interested in, well, for example, in Macau, how many cases of influenza is taking place here every day? Can we get an answer to that? How many cases of influenza is taking place here every day? How do we know it? No one is doing that. But we can find some possible answer if, for example, each of the personal clinic of the doctors is going to report the cases of influenza to a central repository in the Macau government. And then the two hospitals also report to that, and someone in the hospital is going to keep track of that data, and for any persons who would like to have that data, be able to retrieve them, then we could have some sense of how many cases of influenza is happening in Macau every day. Have you ever imagined, now this is very important, in Hong Kong this day, we can always know the number of cases of death owing to influenza. You see that on every week, on every day when you meet the Hong Kong newspaper, they report to you, today 6 more people die of influenza. And so accumulatively, they report, so far as of today, 331 people from the beginning of this year up to today, which is March the 6th, 331 people in Hong Kong died of influenza. How do they know this figures? It depends on someone is going to contribute this figure. Okay? Otherwise, how do you know? How can we trust this is the real figure? So in some way, raw data linking up together could help us to look up to many solutions. For example, the very interesting example given here, if you were a researcher looking for a cure for the Alzheimer's disease in the past, you just look where you are in an isolated discipline of knowledge. But today, with linked data, you can actually look beyond your view and to link it up together with the other scientific discovery, and always, and oftentimes, you can say, breakthrough could often be perceived. So today, we have come to a very interesting perspective of the web. Remember, the theme of this course is called Web Technology and Life. And when we talk about the technology's impact on our daily living, we look at different pieces of thinking. And today's, we look at the data aspect, the way we classify data on the web, and how people can contribute to that, and influence of open data. Today we call it big data here. Okay. All right. I think it's pretty good. Let me tell you what I'm going to do next week when you come back for the third learning contract. And definitely, you know that by the end of this Sunday, you need to submit a learning artifact for your second learning contract, and make sure you do not miss one submissions. Okay. Okay. Even if you have not done a good job, if you, to the best of my understanding, submit it. Do not miss one. That is very important advice. And then next week, when you come back, you can see that our target is week number 8. That is the beginning of the third learning contract, problem-based learning. Okay, so we will try to help you come up with a problem as a team of 4 individuals. Since this is a very good chance for us to do something closely in class with 3 weeks time, based on the field of problem-based learning. That is the cream of the course. Okay, you have 3 weeks time working together, and you need to learn how to work with others. And the best thing is if you have a notebook computer, to bring them here. If not, at least an iPad, or if not, your cell phone could work. Okay, so just make sure you do not miss class for the next 3 weeks. Okay, it's something we need to put things together. And remember, by the end of this Sunday, you need to submit this number of items. Now, I will help you to understand how to use the wiki from the Moodle environment next week, not today. Let's not rush anything, okay? So that's it for today. Let me make sure I finish taking attendance for today. All of you are here. That will be good. Spend some time reading the comments I gave you. I've already given you back all of these assessment for the first learning contract. And remember, the block is very important. All right. Some of you did a good job there. Some of you have not done the block well, but it's okay. This is your path to learning a better way to do something. Okay. Let me create attendance record for today. There is a lot of food for today's class, okay, so make sure you review them, and it's important that you understand the meaning of this course by reviewing the key objectives, learning objectives, and we would like to ensure that you have the ability to reflect on what you learn and the phenomena that is introduced, like web technology in life. And when I read your blog, I would like to see your thinking more closely aligned with the topic of interest you select. Okay? So we thank you for all of you coming back today, and have a nice weekend. Try not to be late. Yeah, it's okay. It's okay. All right. So that's it for today's CISG 114, Section 1, Web Technology and Life. Until next week, stay in tune.